Okay. Alright, so we're going to go into section 7.4. Okay. Alright, so this particular section 7.4, this is probably the most important section. When I say most important section, everything that we've been learning comes together in this section. This is where we actually find the real zeros of the polynomial function. Which basically means you find the real zeros from the factors. Okay, so what if they give you a polynomial and you don't know even one solution? How do you find even that one solution? So first of all, the first concept you want to remember is a polynomial function cannot have more real zero than its degree. What do we mean by that? What do we mean by that? A polynomial function, so if I have a cubic function, can I have more solutions than 3? No, I can only have 3 solutions. A quadratic has 1 or 2 solutions. 1 if it's repeated, or 2 solutions. A quadratic equation cannot have 3 solutions. A cubic function can only have 3 solutions. So the maximum number, a polynomial function cannot have more than what its degree is. Okay. The second thing that so this is it's more a concept. It's more a concept. So when they ask you what are the solutions for this particular polynomial, in your head you should be thinking, okay, I'll probably may get 5 solutions because the degree of this polynomial is 5. Okay. The second and then we move on to something else. This is number of real zeros. Rational zeros theorem. It's a theorem that we talk about. This one is a little tricky, so and you'll see where we won't use it right away. We'll do a couple of things, but I'm going to introduce this. To find the possible rational zeros of a polynomial function, let P be factors of constant. So just write this down. And Q be factors of leading coefficient. Okay, so even if you don't write down what is P and what is Q, it's okay. I'm just going to explain to you what we mean, what we are trying to do here. So you can fill in the blank at any point. So just for now, just listen me out. So this is my polynomial, and they tell you to find the real zeros. They tell you to find the real zeros. Basically means you're not interested in the imaginary solutions. You're only interested in the real solutions. Okay. So I don't even have one solution. I cannot factor this. This is not factorable. So I can't do any of it. So what you start off with what are the possible solutions. So for you to find the possible solutions, you do something called as P over Q. P over Q. So what is P? What is Q? This is basically my P is going to be, this is my P, factors of the constant. So this is your P. As you can see, it's factors of the constant, and this is your Q. And it is not just so you're basically going to write all the factors of P, and you're going to write all the factors of Q. And this is I feel the little tricky part, so I need you guys to stay with me. So for you to find all the potential zeros, you write down P over Q. P is nothing but the factors of the constant, like what we wrote down. Factors of 2. So what are my factors of 2? And it's not only just factors, it's plus or minus. Plus or minus. So make sure you write your plus or minus. So factors of P, which is basically factors of 2, is going to be, what are my factors of 2? It's just 1 and 2. So plus or minus 1. Plus or minus 2 over what is Q? Q is the leading coefficient, factors of the leading coefficient. So which is 6. What are all my factors of 6? 6 are 1 and 6 itself. So you'll always have 1 and its own number and any other factor. So it's going to be plus or minus 1, plus or minus 2. Remember, factors of 6 are 2 and 3. Plus or minus 3 and plus or minus 6. What does this give me? It gives me nothing. It tells me nothing. I don't know what are these numbers. So I actually have to divide it. What does it mean? So what normally we do is we take one numerator at a time. So you take 1 over 1, 1 over 2, 1 over 3, 1 over 6. So my possible solutions are plus or minus 1, because 1 over 1 is 1, 1 over 2 plus or minus half, 1 over 3 plus or minus 1/3, and 1 plus or minus 1/6. These are your possible solutions. What does that mean? That means my solution could be one of these. Okay, so let me backtrack a little bit. I'm going to give you guys a minute to write this down. But I'm not done. We still have to write more. I've just taken one. I have to take two after this. Okay, let's finish this. So you take 1 from the numerator and divide each of the denominator. Then take 2. Plus or minus 2 over 1 is just 2. Plus or minus 2 over 2. What is plus or minus 2 over 2? 2 over 2 is 1, right? But I already have 1 in my list of solutions, so you don't have to write 1. Plus or minus 2 over 3. And my last one is plus or minus 2 over 6. Plus or minus 2 over 6 is 1/3. I don't need to write 1/3 because I already have. These are my possible solutions. Oh, here we go. Sorry, it got cut off. Okay, what does this mean? These numbers actually look a little gibberish and you're wondering what it means. Okay, so let me backtrack a little bit. You're looking at this polynomial. How many solutions do you think this polynomial has? If you're told to find solutions of the polynomial, how many solutions do you think this polynomial has? 4. Perfect. Good answer. And basically what we're saying is those 4 answers, if they're rational solutions, will be in one of these. Basically, any 4 of these could be your solution. We have obviously written more than 4. But basically these are, well, that's why it's called potential solutions, possible solutions. Yeah, the key word is possible. That doesn't mean all of them are solutions. You're looking at possible solutions. And you know what you'll do? You'll actually start doing, so that's why this gets a little complicated. You're going to test each one of them. If you don't have even one solution, you're going to find one solution. From that one solution, you can find other solutions. So the whole idea is to have a list of solutions, and from these solutions, you find your other solutions. Okay, so I'm going to go ahead and write this down. Why don't you guys write this down, and then we'll go to the next page and test each potential for rational zeros by using synthetic division. And you can come back and look at this later, but right now I'll show you something else. Okay, where are we actually going to use this? I'm going to show you, but for now, let's go to the next page, page 15, and we're going to do a couple of problems, and then we'll wrap it up. So here the question is, so if you look at example 3, it asks me, is x minus 10 a factor of this polynomial? Can both of you think of when will x minus 10 be a factor of 2x, and under what condition? What do I need to test for? If it is a factor, what will happen? remainder. Perfect, great answer. It won't have a remainder. When I divide 2x cubed minus 14x squared minus 56x minus 40, when I take this and divide it by x minus 10, I should have a 0 remainder. That's what you're testing for. So test for 0 remainder. Does that make sense? Because if something is divisible, something is a factor, it will have a 0 remainder. How are you going to do? Yeah, okay, I'll let you guys write that. How will you like to divide? There are two ways you've learned to divide. Long division, synthetic division. Which of the two do you think you want to use here? Synthetic division is easier. Does it work here? Yeah, perfect answer, because this is x plus or minus some number. So let's go ahead and do a synthetic division. Write down the coefficient. So 2, negative 14, negative 56, negative 40 in an L-shaped box, and then outside it's x minus 10. You want to write the solution, which is positive 10. And then go ahead and do the drop mama and see if you get a 0 remainder. Remember, you're adding, right? So you drop 2, multiply 10 times 2 is 20, write the 20 here, and then you're adding 20. When you add, you basically keep the sign, so it's 20 minus 14. That's going to be 6. Then you multiply again. 6 times 10 is 60. Negative 56 plus 60, 60 minus 56 is 4. 4 times 10 is 40. And yes, 0 remainder. Yes, it is a factor. Okay. We're going to I'm going to do this B as a practice in the class, next class. So we can do this as a practice, and I'm going to go to example 4. Same concept takes it to the next step. Same concept takes it to the next step, and that's the last thing we'll do for today's class. So let's go ahead and see what they're asking us in example 4. It says factor the polynomial given one solution. Given one solution. So they are giving me one solution. How do I know that's a solution? It doesn't tell me it's a solution, but it tells me this. Basically, whenever you remember, what do we mean by a solution? Something is a solution when you input that value in the equation, it becomes 0. That's why the word 0. That's why this word. So this is what indicates that this is a solution. Because when I substitute negative 2 in my polynomial, it will come to 0. Because remember, how do you find zeros? You basically set the right hand side to be 0. Polynomial equals to 0. That means when you substitute that x, it becomes 0. Okay. So what I'd like you guys to do is, I know for a fact that this is a solution, which means if I take this polynomial, divide it by the opposite of the solution, which is x plus 2, if I do long division, I should get a remainder of 0. So how do you do this division? So let's first make sure that the remainder is actually 0 and we're all good. So x cube. Okay, so what's the concept here? Okay, so let me talk about this. This concept. The concept is, if you're given a polynomial, let's say you have a polynomial x squared plus 5x plus 6. Factors of 6 that add up to 5, 2 and 3. So if they tell you that x plus 2 is one of my factors, when you divide x squared plus 5x plus 6, when you divide that by x plus 2, you should get x plus 3. because these are my two factors. That's what you're trying to do. You know one of your factors comes from -2. If I divide this by this, the remaining thing will give me the remaining factor. That's the whole concept. That's the whole concept. So let's go ahead and divide this by -2 and let's see what happens. So I will again use synthetic division. Let's go ahead and write down the coefficients. 1, -13, 24, 108. Okay. I'm going to use synthetic division, not long division. The reason being, k equals to -2 is a solution. K equals to -2 is a solution. And remember, in synthetic division, I write my solution here. You don't write the factor, but you write the solution. So I don't have to change the sign. You just write -2. And this is 1. You just write -2. Because remember, you write the solution. So it's important for you to remember that. Because -2 is one of my solutions, it's not a factor. If they gave you a factor, please change the sign. But if they gave you a solution, keep the sign. Can we both do drop mama and see what you get? You should get 0 as a remainder because they have told us that this is a solution. Did we get this polynomial? X squared minus 15x plus 54. Please let me know if you didn't so that I can explain it. Yeah, we got it. Awesome. Alright, so remember, what are they asking us for? They're asking us for factoring, right? It says factor the polynomial. So I know I have one of my factors as, because they've given me one of the solutions is k minus 2, I know one of my factors is x plus 2. You both agree with me? One of my factors is x plus 2. What is my other factor? It's x squared minus 15x, sorry, I wrote that, forget that. My other factor is x squared minus 15x plus 54. Is that factorable? There's not much space here, so I'm going to try this here. Is this factorable? X squared minus 15x plus 54. I think it is. 54 is basically 7 times 8. So you want negative 15, so negative 7 and negative 8. So yeah, these are slightly larger numbers than what we'd like to give when you don't use a calculator, but yeah, this is factorable. So which basically means my factors are x minus 7 and x minus 8. Okay, so basically now I found all my three factors. My three factors are x plus 2, x minus 7 and x minus 8. So this is the whole idea of doing the division, because if you can find one factor, you have reduced the x cubed to an x square, and the x square you can either factor or you can use quadratic form. No, you can't factor, but basically for you to find the factors you can basically factor. Quadratic formula you'll use for solving. They're not asking you to solve, but they're asking you to find this one.